Yesterday we used the number line to show solutions to an inequality because there was only one variable solving for x. Today we're going to look at inequalities that have both x and y. So instead of showing our solutions on the number line, we need to use the x and y graphing coordinate. Before we get to the inequalities, let's just remind ourselves of points of solution. So if we have the equation negative 2x plus 3, to graph that we'd have to start at a y-intercept of 3 and follow a slope of negative 2, meaning down 2 over 1, down 2 over 1. And then we can draw the line across. And then we're asking ourselves question A, is the point negative 1, 5 a solution? I could look on the graph and go straight to negative 1, 5, and it does end up being a solution on the graph. I could also use my equation by plugging in the negative 1 for x and the 5 for y. So we'd have 5 equals negative 2 times negative 1 plus 3. And yes, that is true. The next point we could check was 2 comma negative 1. And on the coordinates, 2 negative 1 is here. And in the equation, if we plugged it in as the x and the y, it would also work. If we tried the point 0 comma 0, 0, 0 is here. That is not on the line. And when we plug 0 into the equation, 0 equals negative 2 times 0 plus 3. It's not true. 0 does not equal 3. Similar strategy with inequalities. So this is the same equation as before, negative 2x plus 3, but this time it's an inequality. So I'm going to replot my graph. Because of the equal to line in our y is greater than and equal to, that equal to line tells me that the coordinates that are actually on this line are still solutions. And now we need to decide what other coordinates are also solutions. Our choices are coordinates that are below the line will all be solutions, or coordinates that are above the line or to the right of the line will all be solutions. So the way that we check that is we can pick any coordinate on the graph, plug it into our equation, and see what happens. So for example, if we choose a coordinate out here, like 3 comma 3, we can test 3 comma 3 in our equation and see what happens. So we're going to, or in our inequality, test 3 comma 3. So for y we're putting a 3, for x we're putting a 3. And we multiply negative 6 and plus 3 would be negative 3. And we're wondering, is 3 greater than or equal to negative 3? Yes, that is true. So this point is a solution. All other points on this side of the inequality are also going to be solutions. I could test any point up here and they're all going to work. So we shade this entire side of the graph to show all these coordinates would work and give you true solutions in this inequality. I can show one that doesn't work as an example. If we pick the coordinate 0, 0, and we try to test that, test 0 comma 0, plug it in as the x and the y. 0 plus 3 is 3, and is 0 greater than or equal to 3? And that is no, not true. So all the things on this side of the line don't work. One more example. I'm only going to do problem A here, and I'll let you do the rest. Notice in the problem A, the inequality does not have the equal to line. So when I graph the points, instead of connecting them with a solid line like this, that's for greater than or equal to or less than or equal to. If you just see a greater than or a less than, when you make your line, you're going to make it a dotted or dashed line across the graph. So this one starts with a y-intercept at negative 1. And the slope is negative 1/3. So I'm going to go down 1 over 3, down 1 over 3, and reverse the pattern across the graph. And when I connect the dots, because it does not have an equal to, it's strictly greater than, I'm going to make a dashed line across the dots. And now I can pick a point to test. We can choose a point down below the graph or a point somewhere above the graph. I'm going to choose 0, 0 because it's very easy numbers to plug in. You can choose any other ones that you wanted to plug in. So if we test 0, 0, we're wondering, is 0 greater than negative a third times 0 minus 1? And this would be 0 minus 1, so that's negative 1. Is 0 greater than negative 1? Yes. So this coordinate works, along with all the other coordinates that are kind of on this upper side of the graph up here. And we'll shade this top side. If you got no, then you know that that's the wrong region, and you would shade the bottom side instead. And you could test a point on the bottom half to make sure that it is true in the inequality.